Hello, I'm Anna Mackay and today we're looking at the cosine function itself. So when we're looking at y is equal to cos of x, here is what the graph of that function looks like, and it relates to the unit circle, which we'll go into in just a minute. Noticing the maximums and minimums, at 1 we have a maximum, and that repeats each cycle, each period of 2 pi, and the minimums are at -1. So remember that the cos is related to the horizontal component, the x, if you like, of the unit circle. So we'll go into that in just a second. The general cosine function, because we've already done all the work on the sine function here, is in this format, where the a, the b, the c and the d have exactly the same influence on the function in terms of affecting the period, the amplitude, the dilations, all of those sorts of things. Let's just have a quick refresher on where this comes from the unit circle. So if we have our unit circle, very roughly drawn here, we have 1 out here and -1 out here. And so thinking about the x coordinates of any point moving around that circle for the first period of 2 pi. So when we're at 0 degrees or 0 radians, what will our x coordinate be out to the side here? It would be 1. So that means that the function, the cos function here, bearing in mind we're always doing cos of x in this video, would be up at 1. Now as that moves around the circle, moves around here, what happens to this x coordinate? It's decreasing, it's getting closer to 0. And at what point here will it be 0? At the top there, which is pi on 2. So we have, I'm going to put on what the period's going to be here. At pi on 2, our x is 0. So cos of x is 0. And so that means eventually we're going to connect the dots through, make a lovely picture. As this keeps moving around to what's over here, we have pi over here. We're down at -1. Well, we're across at -1. So that means we're going to have a turning point here as it starts to now go back towards +1 as we come back around the unit circle. And as I'm just going to change colours, as we keep moving around here, we get to 0 again. That our x part of this at 3 pi on 2, we're back at 0. So that means we've got another x-intercept at 3 pi on 2. And then finishing off, as we come back to 1 again, we're going to have a peak up here. Now, I've just noticed this dot here is in the wrong spot. That should be over at pi, so that should be there. My apologies for that one. That makes much more sense now. Connecting our dots, because as we said, our other x coordinate is at 3 pi on 2. So connecting our dots here, this is the function of cos of x in relation to that unit circle. So doing a few questions here. Just looking at in terms of the relationship between sine though, you'll notice that they've got the same shape and that cos is actually the sine curve with a translation that's been involved. So it's had a shift of pi on 2. So if our dashed line here is sine of x, having a look where its peak is, it has peak at 1, but that peak happens at pi on 2. If we shift that whole curve a factor of pi on 2, that peak of 1 happens now at 0 radians, and so on and so forth. It's just interesting. Okay, now if we're asked to graph on the same set of axes, cos and cos of x, take pi on 3. And looking at the period that we're after here, -2 pi up to 2 pi. So first of all, start by thinking about what cos would look like. So I'm going to very roughly draw some things here. So our period, we want 2 pi, therefore let's put in pi as well as some halfway points. And thinking about what is cos normally. So cos at the 0, here has a value of 1. When else does it have a value of 1 after the whole period? 2 pi. Then it has at -1, it has its minimum, and where are its x-intercepts? So that's when our cos was equal to 0. So that's at the top and the bottom of the unit circle, which will be pi on 2 and 3 pi. Whoops, that one's pi on 2 and that's 3 pi on 2. There are x-intercepts. So if you were to connect the dots here, you would have this shape for the cos curve. But we also need to finish that off for the other half of this function. So I find it really handy to put in a few dots to connect them, just to try and get that curve happening. So that is y is equal to cos of x. And now we're being asked to draw a second one. Now, trying to think what shift has happened here. That we've got a horizontal, perhaps I'll write that, horizontal translation of pi on 3. Now, which direction is that going? So it's the opposite to what you would expect there because it's got the negative in the function. So it's to the right. So we don't have too much more information here, but basically that means everything has to be shifted pi on 3 to the right. And well, you think about this x-intercept there. That's at pi on 2. You're going to have to shift that a third, pi on third to the right. So we're just going to do some approximating here, and I'm going to put a dot there. Now you think about this minimum here. That's going to be shifted pi on 3 to the right, and every significant point is going to be shifted. So this x-intercept here shifted a third. It's okay to be rough at this point. The point of this question is just trying to get you to visualize what's actually happening. I'm going to worry about the endpoints right at the end as to what's happening there. So here's our rough graph of cos bracket x take pi on 3. Now, but note that we do need to finish at 2 pi, so we haven't quite had the peak there. It would happen a little bit further over. And over to the left here, though, we have had the peak, had the maximum, so we have to just turn that curve a bit. So that's roughly what that graph would look like. Doing one more here, without technology again, graphing this graph straight away. Let's have a think about what's happened in comparison to the normal cos function. We have an amplitude of what? So if a is 3, and so that a number is that 3 there, instead of having max at 1 and minimum at -1s, where are they going to be now? They're going to be at 3. So we take the modulus of that, just in case that had been a negative number. Whoops, sorry about that. And then what other factors have happened here? We've got the b, so the period. So the period of cos is the same as sine. That's how long it takes until it repeats itself. So that's 2 pi is the period. If that's going to change at all, we take that 2 pi and divide by the b factor. So usually if b is 1, so the number that's sitting there between the cos and the x, it has no change. But here it's 2. So we have 2 pi divided by 2, that b number. That means our period is pi. So thinking about what's happened, instead of the cos wave happening in, say, that amount of time, it's half of that. It's shrunk. So you've got to get that whole cos shape happening in half the amount of time or space, however you want to think about that. So you could think about that in two different ways. The vertical dilation has a scale factor of 3. So that means vertically it's been stretched up to 3 as opposed to just 1. And horizontally dilated with a scale factor of what? So if that period has gone from 2 pi down to pi, is that, what scale factor would that be? It's a half. So don't be misled by the fact that it's a 2 there. Don't think it's been doubled. It's actually been reduced because it's 1 on the b factor there. Okay, and then having a quick sketch of that, what would that look like? In the region of 0 to 2 pi. So quickly, well, you sketch up your axes, you put on your 2 pi and pi, and probably going to need some other ones here of pi on 2 and 3 pi on 2. I still find it useful to often draw the normal cos function to see where you're heading. That would be at 1 down to -1, and that has to start with a maximum and halfway through is the minimum and go back up to the maximum and put in your x-intercepts. So that the normal cos function, y equals cos of x, would look like that. Now, the two changes that we've had here are that the maximum is up at 3, and then the minimum is down at -3. So that's where we're peaks and troughs, and that the whole period has to squish in to fit in pi. So we start with the maximum at 3, and we have to finish with a maximum. But instead of finishing with that maximum at 2 pi, we have to finish with it at 3. So the minimum is halfway along. So this time, instead of being at pi, it's at pi on 2, and therefore our x-intercepts will be halfway between those. So here is one period for this new function, and we need to repeat that again. So put in your significant points, maximum minimums, and x-intercepts, and connect your dots. Label your graph, y is equal to 3 cos of 2x, and you're done. So make sure you subscribe, and the next video will be on the tangent function. Thank you.